everyone, it's Emily here from Eastward, and I'm going to be talking you through today about multiplication and division using something called the CPA approach. Okay, times tables. Times tables are absolutely essential. So there's not much to say on this other than just how important they are. I'm going to give you 1 minute just to have a quick scan of this and just to remind yourself of the times table expectation for each year group. It only goes up to year 4 because the expectation is after that the children should know all of their times table facts up to 12. So I'll give you a second to have a look at that. Okay, I think two things stand out for me. The first one is that it is the multiplication and the division facts. I think quite a lot of the time, and possibly parents especially, think that if the child could do the multiplication, sort of the run up to 12 of that multiplication, they know it perfectly. They don't really. They need to be able to prove that they can do the division facts as well. I think without that, can we really say that they know it? I don't think so. And the 5-second rule, they have to be able to do it within 5 seconds. If they're taking, 15 seconds and counting up on their fingers, obviously that's a fantastic way of doing it at the beginning, but if it's not within 5 seconds, they haven't got it securely. So we have to set the standards really, really high for the children, and there's a balance, isn't there, between encouraging the children as they're sort of going like this and saying, no, that's great, but let's put a timer on now. Or let's see, maybe do a bit of a competition between two, because they have to really get the pace. By the time they're in year 6, if they're sat there counting on their fingers, a very complicated multiplication question is just all going to fall apart. They're going to lose their concentration, and the chance of them getting that question right is little to none, unfortunately. So yeah, all about speed, encouragement, and just cracking it if you can by year 4. Okay, so just a couple of examples here of showing the 5 times table. You could do this for any of the times tables, but familiar to what we've already seen. We've got some numeric on here showing groups of 5. Obviously hands are in 5s, 5 pence pieces, so don't forget always to use money as well. This is the skip counting we saw before, so the numbers are highlighted in multiples of 5 on a number line. The number string, the bead strings, as I told you about earlier, just a classic number line. I've not yet mentioned somehow arrays, so important. Here we have got 2 groups of 5. This is what I was saying earlier about the fact that the multiplications work both ways. Arrays, I think, are one of the absolute best ways to show this, because a child can look at it this way and see that they're looking at 5s, and then they can bend their head round and see that they're looking at 2s. And you can have this on a piece of paper in front of them and swizzle it around and say, oh look, 5 times 2, but then look, if we turn it this way, we've got 2 times 5. And okay, so for the rest of this presentation, I'm going to be talking about the more formal methods for multiplication and division. So this would be the A of the CPA. Okay, so firstly we have column method multiplication taught in years 3 and then into year 4. I will do an example in a little while, but of one of the more complicated ones. But essentially, they've laid it out. Very important to get your columns lined up correctly. They have multiplied first by the 1s. 5 times 4 is 20. They've carried the 2, put the 0 in. Then they've done 5 multiplied by 3, which would be 15. They've remembered to add their 2 to get 17. And then they have written the whole answer out there. Okay, so as you can see, I won't talk through all of these, but they get progressively harder. By year 5, we're multiplying 4 digits by 1 digit, but equally in year 5, we are also doing this. So we are multiplying up to 4 digits by 2 digits. And okay, so here we have that same question. So just to lay it out, 20. Okay, so here we have that same question, 2,739 multiplied by 28. So first things first, just laying it out. Multiplied by 28, so lining up the columns correctly. And then, because this is, multiplying by 2 digits, you want to, I always tell the children to draw 4 lines. Okay, and then you want to be putting your placeholder in, so it needs to be going here. Just quickly on why we put the placeholder here when we're multiplying by 2 digits. We never do this multiplying by 1 digit, but we do it for this because if you think about it, when we're multiplying by the 8 is in the ones column here. This is the tens, hundreds and thousands columns. And so when you're multiplying by the 8, you're multiplying by ones. When you're multiplying by this 2, however, you're not really multiplying by a 2, you're multiplying by 20. So this column is multiplying tens, which is why we put the placeholder here, because then we're starting our answer from the tens column. Okay, so it's important that children understand that as well. Right, so working our way through the multiplication. So 8 times 9 is 72. 8 times 3 is 24. 31. 8 times 7 is 56. So carrying the 5, putting the 9. And 8 times 2 is 16. Add 5 is 21. Okay, and then on to the next column. 2 times 9 is 18. Carrying the 1, putting the 8. 2 times 3 is 6, add 1, 7. 2 times 7 is 14. And 2 times 2 is 4, add 1, 5. And then adding it up. So at this stage, sometimes children get muddled and they forget that, well, they think obviously we've been doing multiplying this whole time. So then now they might start multiplying these numbers again, which isn't a silly thing to do. It's just remembering the kind of order of how we do everything. So now we're just adding. So 2 add 0 is 2, 1 add 8 is 9, 9 add 7 is 16, 4, 5, 6, and 5, 6, 7. Okay, one very quick thing to say that children do sometimes muddle up. Let's just imagine that just quickly draw some more lines here, that whatever it was I multiplied and the answer was, I don't know, 32. Obviously we should be carrying the 3, writing the 2, but you do sometimes get children that will muddle that up and they'll write it 32 like that. And I always just say to them, the thing I found most effective is just to say, you know, that looks more like 32 to me than the other way around. The other way looks like 23. Okay. Okay, so now to think about the formal methods for division. So here we can see some division examples, and they are using what we call the bus stop method. So we have got the bigger number inside the bus stop and the number that we are dividing by on the outside here. Okay, just to talk through maybe this example here, the slightly bigger one, we have got 8,532 divided by 2. So this is how I would talk to the children. So I would say, right, how many groups of 2 go into 8? How many 2's go into 8? 4. Okay, how many 2's go into 5? And then they'd be counting 2, 4, 6. Aha, you can get 2 groups of 2 into 5, but we've got 1 left over, so we have 1 number carried here. Now we've got 13 instead of 3. How many 2's go into 13? 2, 4, 6, 8, 10, 12. Aha, 6. But again, we've got 1 left over. And finally, how many 2's go into 12? It fits nicely, 6. Okay. A little bit more complicated maybe is this example on the left. So where the first number or any number in the row cannot be divided. So here, how many 6's go into 1? 0. So it's important to put the placeholder and then grouping the first 2 numbers together. And then looking at this example here, in this example we have got here, you know, in fact, if I'm following that rule, there should be a 0 here, because how many 7's go into 3? 0. So they should, I would have said, put a 0 there. How many 7's go into 36 would have been 5. Yep, 7 times 5 is 35, with your 1 left over. How many 7's go into 15 is 2 for 14, remainder 1. So at this stage we're using remainders. Okay, the next type of division that we're going to have a look at is where we have division with a remainder again, but this time the remainder is going to be shown as a decimal. So we're going to do 57 and we're going to divide it by 8. Okay, so how many 8s go into 5? That would be none. And then connecting the 5 and the 7, how many 8s go into 57? So that would be 7, because 8 times 7 is 56, sorry, and then we've got 1 left over. So traditionally, or when the children are a bit younger, they would write remainder 1. Okay, but because we want to start doing this as decimals, we are going to use a decimal point. Just a very quick point at this stage. Whatever that is, whether it's remainder 2, remainder 3, remainder 8, that's the number that you use in a second. Okay, I'll show you what I mean. So you put the decimal point, we had remainder 1. So you put a 1 there, and then you put a big 0. So whatever the number was you had left, you put that there. I'm just saying that because a lot of the time people think it's always a 1. The children always seem to think it's just a 1, but it's not. It's whatever you had as the remainder. Okay, so now we're just doing the same standard method. So 8 into 10 would go once, with 2 left over. So again, we do a little 2 and another big 0 to make it 20. 8 into 20 would go twice, 8, 16, remainder 4. And again, you can see the pattern, another big 0. And finally, 8 into 40 goes exactly 5 times. Okay, so that would be your answer. So 57 divided by 8 is 7.125. Okay. Okay, so now we have, again, a division question, but the difference here is that instead of every question we've looked at so far that has been dividing by one number, we are now dividing by 2 numbers. Okay, and this is kind of as hard as it gets in primary school. So there's 2 different main methods that you could use to do this. I'm going to show you them both in turn. They both use this strategy first though, and what I've done, as you can see, is I've written the numbers 1 to 10, and the children you need to encourage them to take a bit of time first to write out that times table. Okay, always good advice just to jump to the 10. They should be able to do that no problem. So 12. Okay, so the 12s are a times table that children are expected to learn, but this could be a much more complicated number. It could be 36, so they will need to take some time to line this all up and have their first 1 to 10 multiples of this times table, whatever the times table is that you are dealing with. Okay, so the first way that we can solve this is we can solve it just using quite a traditional bus stop method as we have seen before. So exactly the normal layout, 432 divided by 12. So how many 12s go into 4? None. And so we connect these together. How many 12s go into 43? And this is where this becomes very useful because I'm looking down my list here. Okay, it's going to end up being 3, isn't it? So it would be 3. So I was at 36. So I was 7 away. Okay, and at this stage you can see now how many 12s go into 72. Looking down my list, perfect 6. Okay, so the slightly different method that I was talking about. So again, we've got exactly the same question. This time, instead of working through the problem like bus stop method traditionally does, what you need to be thinking about is taking away as big a chunk of this number as possible and using your times table knowledge over here to help you do that. Okay, so right, we're trying to get to 432. So I'm thinking about these numbers and what I could do. So I'm having a look down here. I've got 120. I know that 12 times 10 is 120. Well, that's quite an easy number to double to 240. So I'm going to write 240 there. And I'm going to write as a little note over here to myself that that would have been 20. Yeah, that would have been 12 multiplied by 20. So I'm going to put the 20 there. Okay, what is important to do now is that we subtract away this amount to see what we're left with to work out. Okay, so take that away. 2 take nothing is 2. 3 take 4, can't do. Okay, So we're now left with 192. So what could we do now? Well, again, if I'm looking here, I can see that we could just do another set of 10, couldn't we, and take away 120. So this time I'm going to take away 120. I'm going to write over here that I've taken away another group of 10. Now I've got to remember to remove that bit from 192 to see how much we've got left. 9 take 2, and 1 take 1. Aha, and now we've got 72, and if we look down our list, that goes in perfectly 6 times, so that's the only other bit. I've got to write a 6 here, and now 20, add 10, 30, 6. Okay, so exactly the same answer, just 2 slightly different strategies of how to approach it. The first one is more traditional kind of bus stop method, working your way along. The second method is more sort of long division and removing parts of this number that you are trying to divide by bit. Okay, so we're very almost there, everyone. I'm just going to take a couple more minutes to look at some common misconceptions and mistakes that children tend to make when they are multiplying and dividing. Okay, the first one here, I'm just going to work through these one by one very quickly. So the first one is on a number line. If you have a look at the example on the screen there, counting that first place as 1. So children got 1, 2, but of course the first is the first jump. The second one on the list there is lack of the commutative understanding. That's that thing I was on about before, that multiplication goes forward and backwards. If you again have a look at the screen here, 3 times 4 is the same as 4 times 3. So that is really essential. The third one down, numbers times by 0. I just find that so many children muddle that up. It's 0. Anything multiplied by 0 is 0, but children seem to think it, I don't know, they just get really muddled by it. Forgetting the placeholder, of course, when multiplying, that's a common one, which is why it's so important to kind of really emphasise setting up your questions properly, always having that, I always say to them 4 lines and a 0. If you kind of drill that into them, they can't go wrong, hopefully. Lack of connection between fractions and division. Yes, I think this is probably a little bit more towards Key Stage 2, but I think just the idea that fractions and division are essentially the same thing. They are parts of a whole when you have certain parts left over. And so showing children that and making that connection is really, really important. And then just some classic ones. So getting to carry in the correct column, they might miss a column or jump a column, forgetting to add the carried number, it's a classic one, and of course, like I've already mentioned too before, just weak times table knowledge. I don't know how you could get anywhere near those last couple of questions I've just shown you by the time you're in year 6 if you don't have a secure knowledge of your times table. So hopefully, this has been a good reminder for everyone of just how much we need to push the children and encourage them to get on Times Table Rockstars or anything else they might use to practice it. Okay, last little bit. There we go. Thank you. So I've put at the bottom of this video, there will be a couple of links of different YouTube videos of other people explaining more examples of what I've shown you on my whiteboard today. So take a look if you want. And thank you for listening.